Yeah, like I say, we shall be starting from where we left yesterday. So yesterday, we did a couple of things. We learned the basics of OSPF. We checked out how to configure the router IDs, and we did that so well. How to activate OSPF using the router OSPF 10, and 10 was referring to the process ID. We used the network commands to activate router interfaces, and we saw three methods of doing that, and this was actually our reference topology. 3 routers, and we were looking at ways of activating the router interfaces yesterday, and we said we could either, using the network command, we could put all of this network like 10.1.1.12, and then we were to calculate the wildcard mask if we had /30, which is 255.255.255.252. We will subtract it from /32, which is 255.255.255.255. And so if you subtract that, you'll get 0.0.0.3. We look at, of course, how to calculate the wildcard mask, and I showed you guys how to do that. Apart from using the network address, we also had a method of using the IP address of that interface instead of the whole network address. So you say network 10.1.1.14, for example. The wildcard mask you'll use was the quad 0 wildcard mask, which was 0.0.0.0. And then, and then you say area 0. And then the last method was we went to the interfaces themselves and we say IP OSPF. If the process ID is 10, so you say IP OSPF 10 area 0, IP OSPF 10 area 0 on each and every interface. And those are the 3 methods of activating OSPF. So, and we look at the point-to-point networks and the multi-access network. Now, today, of course, remember, we also talked about, before I talk about what happens today, we also talked about passive interfaces. And like I said, passive interfaces are interfaces that are connected to a device that is not a router or a device that we don't know. And I said all interfaces connecting to a LAN, these are LAN interfaces, and any interface going to the internet. All right, so the LAN here, loopback 0, LAN on R1 is loopback 0 interface on network 10.10.1.0, and the LAN on R2 on network 10.10.2.0 through loopback 0. This is also going to the LAN. So all interfaces going to the LAN and any interface going to the internet, we are supposed to make those interfaces to be in passive mode, such that they do not forward any OSPF updates, but those networks can be advertised to some routers. Okay, and that is because of security. For security reasons, because you never know who is listening on that within that LAN or even within the internet. You never know who is capturing those packets. So we should never send any OSPF advertisements out of those interfaces, but we should advertise those networks or those interfaces to other routers. So that's what we did last. Now, today, we want to talk about, remember, one of the things we also talked about yesterday was the network type. And that is where I'm going to start. And he said, there are 2 OSPF network types. The first one is where there's a switch in between, and the switch is connecting both routers. This is called a broadcast multi-access network. And then the other one is when there's a link between a router and a router, a fellow router here. We call that a point-to-point network. So it's always a broadcast network or a point-to-point. The election of the DR and the BDR happens on the multi-access network, or wherever 2 routers are joined together, but they're joined using an Ethernet cable. But if they're joined using a serial cable, through the serial interfaces, then that is actually a point-to-point network. So please get to differentiate the broadcast and the point-to-point network. So like I talked about yesterday, the election of the DR and the BDR, and I was able to observe that, we need to have like a DR so that LSS link set advertisements are only sent to the DR and the BDR, and then the DR will be able to broadcast that to all the routers in the network. Okay, so the BDR, which is the backup designated router, is also listening passively. So the day the DR goes down, the BDR promotes itself to become the new DR. And any router that is not a DR is called a DR other or a drotha, called a drotha. So that's why we were yesterday, and we said we do this to prevent excessive advertisement of LSS within the network, because they can be a burden to the network bandwidth. And every organization budgets for their bandwidth, and they don't want to have any excessive. In terms of the election of the DR, yes.
There's something that I have seen on you. Maybe you didn't mention about if the designated router and the backup designated router, they are all down. So what happens to that network?
Good question. If let's say like in this network, currently R3 is the DR, R2 is the BDR, and the R1 is the only other role it can take is the drotha or DR other. So let me start it this way. If the DR R3 goes down, the BDR will promote itself to become the DR. All right. It means now we don't have any BDR in the network. And so the only other router remaining, if it was only R1 remaining, okay, or even if there are other routers here, then an election is going to take place. An election is going to be triggered. And at this point, I think I need to mention, and I'm going to talk about it, what are the ways of doing an election? Who becomes the DR? Who becomes the BDR? And who becomes the drothas? So at this point, I need to mention that when the router with the highest router ID, like this R3 is having 3.3.3 as the router ID, R2 is 2.2.2.2 as the router ID, and R1 is 1.1.1.1. So normally the router with the highest router ID, it becomes the DR, and then the second highest router ID becomes the BDR. So let's say we had 5 routers here. Okay, so let's say we had 5 routers, and maybe this is another router here. This is maybe this is R4, and we had another router here, and this is here R5. Okay, so if R4, yes, so all these routers, let's say they are all connected to the switch here. So what happens, to answer your question, if the DR goes down and the BDR is available, then the BDR will become the new DR, and an election will be conducted among the remaining routers, so that the router with the highest router ID will become the what? The BDR, and the rest will become routers. If the DR and the BDR, all of them go down, it means the remaining routers, which were routers immediately, they are going to conduct an election, and the router with the highest router ID will become the DR. The router with the second highest router ID will become the BDR, and all the other routers will be the routers. Okay. Now, before the router ID, there's something that takes precedence, which you call it the priority. By default, all routers have a priority of 1. By default, all routers have a priority of 1. Now, if you configure, the priority can range from 0 to 255, by the way. Priority can be configured to range from 0 to 255. And what you're saying, if these routers are having the current router IDs, Okay. And then we change the router, we configured what is called a priority value. So let's say we configure R5 with the highest priority value, maybe 255 for that matter, because that is the largest. Then maybe R4 has a priority value of 100. Then priority will always take precedence before the router IDs. Okay. Any router, the highest router ID will become the DR before. So before the router IDs are considered, the routers check if there's a higher priority value. But if the priorities are the same, which means it's left at default of 1, then the routers will now use the router ID to do the election process. So, but I hope I understand. I answered your question, Nelson.
Yeah. Yeah.
Okay, thank you. All right. So the next thing I was talking about, of course, I've already talked about the DR other and all that. And the only way, and I told you guys yesterday, the only way to know which router is in which state, use this command, show IP OSPF interface, and then put the interface name here. Like show IP OSPF interface G0/0/0. Always look for the word state. State will tell you what is the current state of this router. State will still tell you that that command will tell you what is the current priority. You can see the priority is 1. State will also tell you the cost. Cost is 1. The network type currently is broadcast. The router ID, you will be told here. You will be told the process ID, which is 10. And you'll be told the IP address of that interface, in what area. Okay. And you'll also be told which router is the current designated router, the DR. And what is its router ID, 3.3.3. Which router is currently the BDR, the backup designated router. And the router ID will be given here, plus their IP address of their interfaces. Okay. The command is so powerful that it tells you actually everything about OSPF. So please, this is a very important command. Show IP OSPF interface, and put the name of the interface there. It also shows you, and this is something we're going to talk about today, the hello intervals, all right, and the dead intervals. Like I said yesterday, hello is the amount of time that in the router takes before it can send or receive a hello message from the neighbors, all right, or to the neighbors. And the dead interval is the time that this router is waiting, such that if 40 minutes elapses before this router sees any hello from the neighbor, then it knows the neighbor is down, and it will actually declare the neighbor down and remove the router from its routing table as a neighbor, and even from its neighbor table. Now, one thing I didn't mention yesterday or in our previous class is the fact that normally dead is always 4 times the hello by default. By default, dead, which is 40, is always 4 times the hello. And 10 is 10 seconds, and 40 is 40 seconds. And so when you configure hello as 10, because we will be configuring hello today, you must configure dead as 40. If you configure hello as 20, you multiply by 4, it means dead will be 80. Very important. Why are they important? Because these ones are always configured on per interface basis. And if 2 routers are connected by a link, and one side you configure hello to 10, and the other side you configure hello to 20, they will not establish any neighbor adjacency. Very, very important. They will never establish an adjacency. And that's how important the hello actually are. So so that is about hello and the states of each router, the DR, the BDRs, and all that. I mean, there's a command here, show IP OSPF neighbor. If you want to view the neighboring routers within your network, this is a very important command, show IP OSPF neighbor. And the state of the neighbors in a multi-access network can always be full to Drotha, which means one of the routers shall have achieved a full adjacency, but the neighbor is actually a Drotha, it's not a DR. Or the routers have achieved a full adjacency, but with a DR, or the routers achieved a full adjacency, but with another router which is a BDR. But sometimes you'll see two-way and DROTA. In two-way and DROTA, it means the routers have not achieved, they have not converged yet. There is no full adjacency established. And the router on the other side is actually a non-DR or is a BDR router. Okay. But the routers are actually exchanging some hello messages amongst them. So that is very, very important. But the normal state for our routers is it should have a full state. Very, very important. Anything on two-way, you want to troubleshoot and just see what the problem actually is. Okay. So you'll always see when you say show IP OSPF neighbor, you'll see the router ID. The router ID is important because that is what is used to identify each router. So the state will be here. It will be in full state. So the router on the other side will be a BDR, or it will be in full state, and the router on the other side will be a what? A BDR. Okay. So that is that. I talked about the election process of the DR and the BDR, and we say that for the election of criteria, the first criteria used is always the priority value. The priority value can range from 0 to 255. Okay, but by default, the priority value is always 1. But you can actually configure it. If you want a router to always become the DR, then you give it the highest priority of 255. Okay, but in case you leave the priority to be at default of 1, okay, then the routers will now choose the router IDs to become the criteria for election of the DR and the BDR. Okay, and that is, I told you that the router ID can be identified in 3 ways. Number 1, you actually manually configure it like we did yesterday, or the router will choose the highest IP address of the loopback interfaces, or if there's no loopback interface, then the routers will actually choose the highest IP address of the physical or active interfaces that are not loopback. So there's no way out of it. These are, the criteria that you use for doing that. Okay. Now, so this is what I think Nelson was asking. What if the DR fails? Okay. Or the DR fails, or it is stopped. The process is stopped, or the DR is actually shut down. What happens? So I already explained that the BDR will always be promoted to become the DR, and then the routers will have a higher election and choose the highest priority or the highest router ID to become the DR and the BDR respectively. So that is very important for the process of failover between these networks. So it just depends on either the priority value or the election using the router ID, something which I already talked about. But how do you configure priority value? And the command is very simple. By the way, I'm going to take you through an activity where we are going to configure all those things, and I'll definitely show you how they work. So how do you configure priority value? Change it from default of 1 to something 255. The command is IP OSPF priority, and you can actually see that here. You go to the interface, G00, and you say IP OSPF priority, and put any number between 0 and 255. If you put number 0, that router will never become the DR or the BDR. Very, very important, because that is the lowest priority. All right. So IP OSPF priority 255, 100, 2. Yeah. Yesterday, I think I also talked about this. Every time you want to change the priority or the router ID, after the router had already chosen its own router ID, you must use this command to restart the OSPF process. Don't restart the router, restart the OSPF process. Say clear IP OSPF process, press enter, and you need to put a Y there for yes, so that the whole thing can take effect, okay? So that those changes can take effect. And now you can be able to see that the priority is now 255 here, and it's actually the DR right here. So a couple of steps. a couple of, just things for you to check. So having an activity like this, for example, and let's say we have this here, and we are told that use the OSPF priority command to change the DR and the BDR as follows. So we are told R1 should be the DR and the BDR, and will be configured a priority of 10. See that? R2 should never be a DR or BDR, and we give it a 0. So we use a BDR, a priority of 0, that router will never become a DR or a BDR. And R3 should be our DR, and we give it a priority of 100. Okay. Okay. All routers use the G00 for the interface name. So you need to enter you're now logged into R1, configure R1 with the priority of 10. So we say, get into that interface, G0/0/0, say IP OSPF priority, and this is R1, so give it 10. Enter. We are in R2, get into interface, G0/0/0, and say IP OSPF priority, and this is R2. We are told R2, we give it 0. And then we get to R3, and you say interface G0/0/0, as we are told, IP OSPF priority, IP OSPF priority 100. Okay, so we are now logged into R3, interface configuration mode. We need to return to privilege exec mode because R3 is to be a DR. So we need to go to the privilege. So go to the privilege, you have to end. And then we are told we need to restart the OSPF process first. So we say clear IP OSPF process, cancel with a Y, and press enter. We do the same in R1. Say clear IP OSPF process, cancel with a Y. We do the same to R2. Clear IP OSPF process. Cancel with a Y. Yeah. We are now logged into R1. We need to read the details of interface. OSPF settings on interface G00. We say show IP OSPF interface, show IP OSPF interface G0/0/0. Okay. Show IP OSPF interface G0/0/0, and you can actually see here that, of course, the hellos are 10, dead are 40. Current state that R1 is the BDR, as we are told, because the priority is 10, as we have configured. Network type is broadcast. The cost is actually 1. We are going to talk about that cost in a little bit. Router ID of R1 is 1.1.1. Process ID is 10, and we are in area 0. The current, designated router is 3.3.3. That is the DR, and the backup designated router is actually R1, where we are right now, 1.1.1. Like we say, hello is 10, and dead is 40. And so is those. So let's do the same. We are now in R2. Use the show IP OSPF interface G00 command to verify that R2 is the router. We say show IP OSPF interface G0/0/0, and we are now logged into R3. We are now logged into R3. We can look at the one for R2, and we say the state of R2. We can see the current state here. R2 is the router. The priority is 0, as we did. The DR is R3, 3.3.3, and the BDR is actually R1 here. And hello is 10, that is 40. This route ID is 2.2.2, R2, process ID is 10, so on and so forth. Let's do the same for R3, who is the DR. We say show IP OSPF interface G0/0/0. And look at this. This guy is currently on area 0. Okay. The network type is broadcast. The course is 1. Router ID is 3.3.3. Process ID is 10. The state currently of this router is the DR. Priority is 100. The DR is actually our local router right now. 3.3.3 is the router ID. Its IP of the interface is there, and hello is 10. Dead interval is also 40 here, so 40 times, as we had already mentioned. So very, very important information there. So one of the first assignments I'll be giving you guys is here, determining the DR and the BDR. So someone to just note that down. 2311. 2311 is one of those activities that I will be needing you guys to configure. Let's talk about the cost. And talking about the cost here, every dynamic routing protocol, whether it is EIGRP, it's OSPF, it's RIP, it's ISIS, it's BGP, has what we call a metric. And because we are talking about OSPF, the major metric for OSPF is actually cost value. All right. And this is OSPF uses a cost value, and the cost has nothing to do with the money. And normally the lower the cost is always the better the path than the higher cost. So a low cost on a path, and by the way, the metric is just the distance to reach a certain network. So the lowest the cost is always better. Higher costs are not preferred by OSPF. So OSPF will choose to send traffic towards a lower cost. Okay. So the cost is actually is inversely proportional to bandwidth on a particular interface, and that's why the higher the bandwidth, the lower the cost. And the formula normally used to do that, of course, is here. To get cost, you need to take your reference bandwidth divided by the bandwidth of the interface. And the reference bandwidth is actually a default value, which is always 100 million or 10⁻⁸. So 100 million, you divide by any bandwidth on the interface. And when I talk about interface bandwidth, when the interface is gigabit Ethernet 0/0, you know that is 1 million. It's actually 1 billion. The default BPS on the interface is 1 billion. So if you have if the reference bandwidth by default is 100 million, so you always divide that by the interface bandwidth. An interface of fast Ethernet, which is always 100 Mbps. If you convert that 100 Mbps to BPS, the bits per second, you will actually get 100 million. So that will give us a 1. If an interface is gigabit Ethernet, which means it's 1,000 Mbps, you multiply that again by 1 million, and you actually get a billion. And if you divide by the reference bandwidth, you'll get a 0.1. And if an interface is 10 gigabit per second, which means you multiply that again by 1 million, you actually get 10 trillion here, or actually get 10 billion. And so you divide the reference bandwidth by that amount, you get 0.011. Now, whether the interface is 10 Gbps or 1 Gbps or 100 Gbps, it's always taken to the whole number. And that's why all these ones will give us 1. You always round it off to the whole number. And you see that the cost will be 1 here. Even though the answer is 0.01, they round it up to a whole number. All right. So whether it is 0.01 or 0.1 or even 1, all of them will have the same cost due to the reference bandwidth parameter. Okay. The only interface that might have a higher cost is actually be a 10 Mbps, which is an Ethernet port, where we multiply the reference bandwidth by 10 million, and you actually get 10. So as we'll be learning today, that there's a command that can be used to synchronize all interfaces that are gigabit Ethernet interfaces or fast Ethernet to basically, so it's a command that I'll be showing you used for synchronizing the cost along these interfaces. Even though there's a formula for configuring manually the interface, but this command here, autocost reference hyphen bandwidth. Okay, the autocost reference hyphen bandwidth is actually used to automatically configure the particular interface. When an interface has a speed of or a bandwidth of 10 GB, I mean 1 Gbps or 100 Mbps, it actually synchronizes the cost on those particular interfaces, including the bandwidth. So this is a very common command, autocost reference hyphen bandwidth, and we will be using it to basically be able to reference the cost. Okay, using that particular calculation in the reference bandwidth, we will need that, the bandwidth of the Gbps. I mean, the cost will be 10 for the Gbps interface, and for the fast Ethernet interfaces, the cost will be 100. So that is the command that we do here: autocost reference hyphen bandwidth. So if you do autocost reference hyphen bandwidth and you put 1,000 on there, that is actually going to level up things for you. So we'll be doing that particular configuration. So that is for the reference bandwidth. Now, instead of using the autocost reference bandwidth to actually synchronize, to make bandwidth to be consistent across all your router interfaces in that domain, you can actually configure a manual OSPF cost, and that is always very direct forward. Just need to say IP OSPF cost, IP OSPF cost, and that's it. IP OSPF, yeah, that's for manual configuration of bandwidth. For example, if you're given this topology and you're told configure the interface on this link to be 10, I mean the cost of this interface to be 10, and the cost to be 10, the cost to be 30 here, 10, 10, so on and so forth. That is very straightforward. Just go to the interface, use 001, for example, and say IP OSPF cost 30, go to interface loopback 0, IP OSPF cost 10. So these are very, very basic ones, basic commands if you want a bandwidth for specific interface. But if you want to apply bandwidth consistently across all your interfaces, then use the autocost reference bandwidth command to be able to do that. And we are actually going to work on that on one of our activities there. Now, if you are in my previous class, I think I have taught you guys before how to read the routing table. The routing table is always read horizontally, such that you start with what is here, the O here. It means how the route was learned, which dynamic routing protocol. So in CO, obviously that is OSPF. The next one is always the remote network that was learned, and that is here. It's 10.1.1.8/30. This is the remote network that was learned. Then you find two numbers inside a square bracket, and the first one is 110, which is the administrative distance of OSPF, and the next one will be the metric. The metric separated with a slash from the AD. The metric is 20 here. The next value will be the next hop IP, the next hop IP address, and the next one will be timestamp. How much time has elapsed since that remote network was learned? Then the last one will actually be what? The last one will be the exit interface. The exit interface. All these things are things you have studied before. If you need to remind yourself about something, you know where to find the link to some of these ones. Check on the last two chapters in CCNA2. The videos on that particular channel are actually put in terms of playlists. So there's a playlist for all CCNA1, and then there's a playlist for all CCNA2, and I'm currently building up the playlist for all the CCNA3. And so that's how we read the routing table, and it's a very important scale for you guys to do what? To learn. Now, the cost is a very important one, and it can actually make your router to go down if you change the cost on a particular interface. So it's very, very important for you to always make sure that some of those settings are actually left unchanged. So in terms of configuring the cost, here is an example, like I told, to get into interface, blueback 0, and you say IP OSPF cost. The cost is 10 there. We return to global by using exit, and then we need to end. Then we need to verify routing entries. Say to view the routing table, show IP route. Now, if I say show IP route, I will actually see all the routes in the routing table. But if I want to see only OSPF routes, then I must add the word here, OSPF. Let's say show IP route OSPF. Press enter. I will only be seeing the OSPF routes only routes that have been learned. This is our router using OSPF. Okay, we can do the same to this interface in R3. We need to get into interface LO0. We need to set the cost to 10 to say IP OSPF cost, that is 10. And then we need to use interface G0/0/0, and we need to set the cost IP OSPF costs, and the cost is 30. Then you need to return to privilege exec mode with the command end, and you need to view the OSPF routing entries within the routing table to say show IP route, show IP route OSPF. And you can see our OSPF routes are actually right here. Okay. Now, so that is for the cost, and I'm actually going to work on a particular activity here, which combines all those activities, and we'll see their implementation within a network. Now, I have been talking to you guys from yesterday about the hello intervals, or the hello messages, or the hello packets. And here we talk about the hello intervals, and the sister of hello interval is actually the dead interval. We know that the hello packets are always transmitted using the multicast address of 224.0.0.5 to all routers that have been activated with OSPF. We call them OSPF routers. And those hello messages are always sent after every 10 seconds by default. But of course, we can change this. So all the point-to-point and the multi-access networks, they have that default value. Okay. And like I said, hello packets are not sent on interfaces that have been set to passive, as we had already seen how we set interfaces to passive. And then now that we've talked about the hello, we also have the dead interval, which is always 4 times the hello. So if the router waits for 40 seconds, before receiving any hello interval, then the router will declare the neighbor down. Okay, so that is what is called the dead interval. Okay, and so it is important that that value of hello, we can actually change it, but you must observe that 4 times value to be able to do that. And if you, like I had mentioned to you, if you set a wrong hello on one side and a different hello on the other side of the link, then that link between two routers is actually going to lose adjacency, and it means traffic is not going to be moving. And that's why it's important to keep those messages very consistent within your network. So you can actually always change the hello. By default, we say they have 10 and 40. If you want to change them, then you must observe that. So how do you change them? Very important. So go to the interfaces and you just need to say IP OSPF hello hyphen interval. If you put hello 5 here, make sure you multiply 5 by 4 and you say IP OSPF dead hyphen interval 20 multiplied by 4. Then go to the other. The moment you do that, by the way, the interface will go down. The interface is going to go down. And how do you know the interface has gone down? You'll see this neighbor having a router ID of 2.2.2.2 on interface G00 has changed from full to down, right? From full adjacency to down, and the neighbor is actually down, and the timer has actually expired. Very, very important. And so when you say show IP OSPF neighbor, you see that the state is currently full, but without any neighbor here. Okay, very, very important. So you need to go to the other side, set hello by saying IP OSPF hello interval. Also set hello to 40. Set hello to 5, and the dead should actually be set to 20. Okay. All right. So that is that. That is that for the timer. That is that for the timer. So you need to, once you balance that, then everything is going to be okay. We can do a few modifications here before we do the final thing, which is on some static routing. Now we are logged into R3, and you're told we need to show IP OSPF neighbor. Let's check if this router has some neighbors. We show IP OSPF neighbor. So if you do that, you realize that this router currently does not have any neighbors here. Okay, no results are returned for the neighbors. So it means something is wrong, and we need to fix it out. So we need to use the G00 as the interface name and configure hello interval to match that of R1. You know that hello interval for R1 was actually 5, and the dead is 20. All right, so we are going to configure both of them on R1. For R1, 5, hello is going to be 5, and also hello to match on R2. So let me see. Oh, hello didn't interval for R1 and R2 are both of them are 5, 5. So that's okay. So let's get the interface G0/0/0. Say IP OSPF hello hyphen interval, and you put it to be 5. And you see the neighbor has come up. So there's a new neighbor change. Neighbor adjacency has been achieved. And the neighbor is 1.1.1, and it has moved from loading to full, and loading is actually done. We go to the next interface, which is interface of R3 connecting to R2, G0/0/1, and say IP OSPF hello hyphen interval, IP OSPF hello interval, and you put it to be 5 as well. And you can see it has moved from loading to done. A new adjacency has been achieved. And then now we need to verify neighbor adjacencies that they have been reestablished. So we need to return to privilege exec mode with the command and they say show IP OSPF neighbor, and you can see that we have 2 neighbors here. Move to full. We might not be knowing the state of those neighbors, but we do know that the adjacencies have been achieved, so on and so forth. Yeah. And that brings me to another assignment that I'll be giving you guys in modifying the single area OSPF. I will need you guys to work on 2.4.11. Please note that down, and the class representatives will post that in the group. 2.4.11. All right. So having talked about that, we just want to talk about one more thing before I take you through my, all those things that I've talked about. I want to talk about just one more thing, and this has something to do with what we did during the previous semester. We talked about something called static routing, and we talked about something specifically called the default static route. Okay, and so R2 currently is the one router that is connected to the internet. R2 is also connected to R1 and R3. All right. And so listen to this. R2, since R2 is the only router connected to the internet, R2, you realize definitely that it has a storage. It has a storage unit for itself, or a storage memory. And one thing we can agree on is that normally the router has a limited size of memory, and the router cannot store all the routes within the internet, because we know the internet has millions and millions of routes over there. So R2 cannot store all the routes in the internet. And so to make our work much easier, what we could do is we could do a universal route which can be used to reach all the routes in the internet. And that is what we call a default static route. So we install one route. Instead of storing all the routes in the internet within our router R2, we can actually configure a universal route, which we call a default static route, which can be used to reach all the routes within the internet. Now, if we do that, we can only do that in R2, all right? We can only do that to R2, since R2 is the only router connected to the internet. But we can actually make sure that R2 can actually distribute that route to R1 and R2. So that if R1, which is not R1 and R3, which are not directly connected to the internet, if they need to send something to the internet, then they can actually use the default route that has been distributed to them from R2. And that is actually done using some command. So all of us, we know that this command here, we learned it in the last two lab chapters during the previous semester. We say IP route, and we use the 0.0.0 as the network address, 0.0.0 as the subnet mask, okay? And then we put either the next hop or the exit interface. I taught that class very well. Please check at chapter 16 and 15 of CCNA2. You can check it in our YouTube channel, and you will be able to see all that information very well described and very well illustrated. All right. So once you configure the default static route facing the internet, of course, you use the interface facing the internet or the next hop if you know it. And then the command to distribute that default route to the other routers within the network is default-information originate. Default-information originate. And I think there's an example here. Let's say this diagram here, that loopback interface is the interface connecting to the internet. So what we want to do, we want to configure the default route with the exit facing the internet. And that is what is actually here. So of course, the loopback interface facing the internet, it has its own IP address here already configured. So we need to configure default route and to say IP route 0.0.0.0, 0.0.0.0. Then you put the loopback 1 as the exit interface facing the internet. And then now we need to say router OSPF10. Then we need to distribute that route within OSPF. So command is default-information originate. So as OSPF will be exchanging the routing updates, it will also be exchanging the default static route to other routers within the network. So we say OSPF will be distributing the default static route to its neighbors, And of course, that is always verified. If you say show IP route, one way of identifying the default static route, you will see it with the router that has been configured with it, you will see it with S and asterisk. S and asterisk, it means when you see the S, it is a static route. But when you see the asterisk, it means it's a default route. So we call it a default static route, and it acts as the default gateway of the router. So this is how you see it on the router where you have configured it. And you know, it is from this router that we are going to distribute it. Now, we are in R2, we want to distribute it to R1 and R3. So how do you see the default route as having been learned using OSPF? So when you say show IP route in the other routers, you'll not see the S and asterisk. You'll see O, which means this route has been learned via OSPF. But the fact that you see the asterisk there, it means it's actually a default route. And then you'll see E2, which means it is an external type 2 route. It is a route that has been imported into OSPF. It has been learned into OSPF and then distributed to the neighbor. So O asterisk means it's learned through OSPF. The asterisk means it's actually a default route. And then the E2 is actually means it's an external route distributed right within OSPF. Very, very important. The rest remain the same. This is the default network. 0.0.0 was learned. The AD will still be 110. The metric is 1. The metric always will be 1, of course. The next hop will be 10.1.1.6. The time interval, how much time has elapsed since the remote network was learned? That is 11 minutes and 8 seconds. And then the exit interface was G0/0/0. Okay. And of course, there's an activity here as well. Please note this as well. 2.5.3. 2.5.3 is the other activity that you will be working on. You'll be working on 2.5.3, and that is the other activity you guys will be working on. Now, in terms of verification, of course, I will always need you to do verification. Show IP OSPF neighbors to verify who the neighboring devices are. Show IP protocols to view the protocol settings. These are very important OSPF protocols. Show IP OSPF and even show IP OSPF interface. Very, very important verification commands that should be at the at your fingertips. Okay, very, very important commands for for really dissecting the settings of OSPF on each and every device. Show IP protocols. The command used for viewing the router IDs, OSPF process ID there, the passive interfaces there, the current neighbors are here, and the interfaces currently available for routing. Show IP OSPF, of course, gives you so much information about OSPF within the whole of your device and each and every interface. Show IP OSPF interface D00. I already talked to you about this. It should show you the type of network, the cost, the process ID, the router ID. It will show you the hello intervals, the dead intervals, the current state, that interface. If it's point to point, you'll not see the DR and the BDR, so on and so forth. So show IP OSPF interface brief, of course, gives you a brief listing of your interfaces, so on and so forth. So work on, and there's a syntax checker here that you can actually use for practicing the show commands. And having done that, you can also work on 266 for verifying the OSPF processes, 266 verifying the OSPF processes. Now, right now, ladies and gentlemen, is that time that I have been waiting for here to be able to take you through all those things that I have actually talked about. And so I'm going to work on one of the assignments. I'll not tell you which one, but I will give I'll give it to you also so that you can be able to work on it. So this is how it looks like. I actually want to reset it. I want to power cycle my devices so that I go from, I take it back to 0. Okay. I can actually close this one. Then save it, and I'm gonna download it afresh. This is for single area configuration here. Yeah, I wanted you to just basically start from the very beginning so that we start from zero, start from the basement. Okay. Yeah, so here it is just loading afresh. Let's see how it goes here. Yeah, so this is, I want you to pay so much attention to it because you are going to learn so much from it. Everything that I have taught today, we are going to see it here. Okay. So okay. Yeah. So this is the topology, the activity that I'm going to talk about, and it's actually at 0%, and we need to configure it to get to 100%. Very interesting. I was trying to increase the size of it all, but it's unfortunate that it's not able to do that. But anyway, I think it still can. Let me see if I can. All right. Yeah, I think it's visible. So we have two kind of big networks here. We have the networks under the headquarters network, and the headquarter is actually, yeah. So the headquarter is actually router P2P1. It's like point to point. So P2P1, P2P2, and P2P3 are found under the headquarters network. We have the data services network, which again has 3 routers, BC1, BC2, and BC3. Okay. And of course, BC1 is connected to the ISP cloud network. The networks within the data services is actually a multi-access broadcast network. And the networks within the headquarters are point-to-point network. So we are going to, let me just give you a background of what's happening here. And so reading across, our objective is to implement single area OSPF version 2 in both point-to-point and the broadcast multi-access network. And like I said, this is a point-to-point network. This router is here. And this is a broadcast multi-access network. The networks, you can see they are joined together using a switch in the middle here. So this is where we're going to have the election of the DR and the BDR. And that kind of election is never found on a point-to-point network. All right. So we are told you are helping a network engineer test an OSPF setup by building the network in the lab where you work. You have interconnected the devices and configure their interfaces and have connectivity within the local LAN. But your job is to complete the OSPF configuration according to the requirements left by the engineer. Now, use the information provided and the list of requirements to configure the test network. So when the task has been successfully completed, all hosts should be able to ping the internet server. I hope you guys saw the internet server. The internet server is the device that is connected on this other side of the ISP cloud. We're going to see that, of course, in a short while. And so let me take you through a couple of things that we're going to do here. Not so many of them, very, very precise instructions. So we are going to use a process ID of 10 for all router activations of OSPF. That's very clear. Next is we are going to activate OSPF using the network statements and inverse masks. You know what an inverse mask is? That is the wildcard mask on the routers in the headquarters network. So the first thing, we'll configure the 3 routers within the headquarters network. Then we'll activate OSPF by configuring the interfaces on the network devices in the data center service. So we are going to configure interfaces. And you know that command? IP OSPF 10 area 0. You know that command that we did yesterday. And then we are going to configure router IDs on the multi-access network routers. And there are our router IDs. Router BC1 will have a router ID of 6.6.6.6. Router BC2, 5.5.5.5. And BC3 is 4.4.4.4. And then we configure OSPF so that routing updates are not sent into the networks where they are not required. So that is, if you remember, passive interfaces. And then we will configure BC1 with the highest OSPF interface priority. You know, the highest priority is 255, so that it will always be the designated router on the multi-access network. Good. Then we configure a default route to the ISP cloud using the exit interface command argument. So here is the default route. And when we configure default route, we have to automatically distribute that default route to all the other routers in the network. And then we configure OSPF router so that the gigabit Ethernet interface cost will be 10, and the fast Ethernet cost will be 100. So this is where we do auto-cost reference bandwidth. We put 1,000 to be able to make sure that this the costs are actually synchronized very well. And then we configure OSPF cost value for the P2P1 interface serial 011 to 50. Then we're going to configure the hello and dead interval values on the interfaces that connect P2P1 and BC1 to be twice the default values. You know, the default values are 10 and 40. So we do that on this interface. So let's get started here, ladies and gentlemen. So we start with you're told activate OSPF network statement and inverse masks on the routers in the headquarters network. So here is the headquarters network here. So what I will actually do is I can just push this a little bit, and I will start with this router here, P2P1. And in P2P1, I will obviously do enable and do conf T to go to the global configuration mode, and I will say router OSPF 10. Okay. And because I'm using the network statement with the reverse inverse mask, I say network. So I will start with I could actually start in any order, but I'll start with all the directly connected network on P2P1, which is this one, 10.0.0. So we'll say network 10.0.0.0. The wildcard mask is /30, that is 252. So the wildcard mask will be 0.0.0.3. Then we say area 0. That's done. There's a problem somewhere. Oh, I used the word network twice. Thank you for that. So I will need to remove the first one, and that will be okay. So I've already added this network here. So the next one, I can add this one, the next directly connected. So I'll say network 10.0.0.8, as you can see there. Second network is 8. The wildcard mask is /30, so that will be 0.0.0.3. That is 252 from 255. We get 3, and say area 0. And that is good. Now, right now, you will not see any adjacencies being achieved. Remember, an adjacency only achieved if 2 routers have been configured with OSPF. So right now, we are only working on P2P1. So the moment we go to P2P2 and even P2P3, you'll see some messages popping up of an adjacency change. So we do the last one on this P2P1, is this network here. And we say network. And that is 10.0.0.12. It's /30, so 0.0.0.3, and we say area 0. All of them are area 0 because we are working on single area. And that's good. Then we go to P2P2. Can minimize this and go to P2P2. Put it here. All right. So let's go to P2P2. I go enable. I say configure terminal. And then I'm going to say router OSPF10. Activate OSPF. And then I now need to, let's start with the, we are in P2P2. Let's start with the first directly connected network shared between our one P2P1 and 2. Let's say network. Put 10.0.0.0 space 0.0.0.3 as the wildcard mask and I say area 0. Look at what's going to happen in the next few seconds. So now press enter here. Give it a few seconds and you can see this, a new neighbor has been learned. And that neighbor is having a router ID of 10.0.0.13, and the loading has moved from full loading to full. And right now, if I said do show IP OSPF neighbor, you can see this router currently has one neighbor. All right, there's one neighbor here. We don't know they have moved to full adjacency, but they have not done election to determine they're not going to do any election because they are on a point-to-point network. All right, that's a very good one. So let's continue. Let's configure other directly connected networks. Remember, P2P2 has 4 directly connected networks. We have just done the first one. We could go to the next serial. We see network, and it is 10.0.0.4. The wildcard mask is 0.0.0.3, and we say area 0. Enter. You might not see an adjacency on network 10.0.0.4 because we have not configured anything, the other route on the other end. But let's do this other LANs here. We say network 192.168.1.0 and /24. That's going to be 0.0.0.255. We say area 0. I hope you guys know how to calculate the wildcard mask and do the last network. We say network 192.168.2.0, and the wildcard mask is actually /24, which will be 0.0.0 subnet mask 24, so 255, and you say area 0. Area 0. That's it. So we are done with this router. We now need to move to P2P3. And here we'll see a couple of adjacencies. That we'll see in P2P3. Do enable en conf t. And then we need to activate the interface. Let's start with the interface connecting to P2P1 10.0.0.8. You see router OSPF10 and say network 10.0.0.8 /30 is 0.0.0.3, and you say area 0. We expect an adjacency. Give it a few seconds. Boom. There we go. A neighbor on 10.0.0.13. Let's go to P2P3 has 3 directly connected. We've already done 10.0.0.8. We do 10.0.0.4. So we say network 10.0.0.4. It is actually /30, so 0.0.0.3, and say area 0. And we expect another adjacency from P2P2. And let's wait and see. There we go. You can see an adjacency has been done on 192.168.2.1. That must be from this guy is learning so many networks here because we have activated OSPF. So it's going to learn a couple of them here. Let's activate the interface here. Network is the one down here, 192.168.3.0. Remember the subnet mask is /28, so that is like a 240 at the end. So we say 0.0.0.15. Please check your wildcard mask, very important. Area 0. I forgot to show you guys, we should be showing if we are making progress. And from what we can see here, we're actually making progress. We are at 20 right now, 20%. And we are now at 22. So let me take an example of these routers. Let me just say, do show IP route OSPF. We expect to see some OSPF routes here, and you can see them here clearly. This router P2P3 has automatically learned all these remote networks here. It's learned 10.0.0.0, 10.0.0.12, 192.168.1.0, and 192.168.2.0. So those are the remote networks for this router P2P3. So you can see 192.168.1.0, 2.0 is here, 10.0.0.0, and the other one is 10.0.0.12. So those are the remote networks for that router. And we have actually been able to achieve that. And if we check that in the other routers, we'll definitely see the same thing. So that was the first thing. The next instruction says, activate OSPF by configuring interfaces of the network devices of the data center, data services network where required. So let's go to the data services network, this network here. We have 3 routers. We start with BC1. We're going to activate all its interfaces. So what we can do is, I could bring this router here, since we are not using networks, and I could just go here and say conf t. I will say do show IP interface brief to view my active interfaces. You can see the first interface is here, G00. The next one is S00010, and the next one is S011. So those are the currently active interfaces having IP addresses on them, which means on BC1 is the link from the point-to-point network, the link to the ISP, and the link to the multi-access network here. So let's say we start with interface G0/0/0, and we say IP OSPF 10 area 0. IP OSPF 10 area 0. You will be checking as our marks are actually adding up. So IP OSPF 10 area 0, and we have 25 now. We do the same on G001. So I just need to use the up arrow key, go to G01 and use the same command, IP OSPF 10 area 0. And that's it. And the last one is S011. S0/1/1. And I say IP OSPF 10 area 0. And I'm having 25 marks there. All right. So having done that, I can now be able to do the next instruction, which says configure router IDs on the multi-access networks routers. So the multi-access network routers are actually routers BC1, BC2, and BC3. So I need to just do here exit, because I need to configure the router IDs. So BC1, I need to say okay. BC1, I need to say, so router OSPF 10. Okay. And then I need to say, okay, I need to say the router IDs, as we did, say router -ID. And because this is BC1, we are told BC1, the other ID is 6.6.6.6. Enter, exit. Then I need to go to BC2. BC2 is here. And I need to conf T. So I need to say router OSPF10 and say router hyphen ID, and use a tab key there, and put 5.5.5.5. And then I need to go to BC3. And in BC3, conf T, and I need to say router OSPF10, and then you say router hyphen ID. The ID is 4.4.4.4. And that's done. That's done. Now, having changed that, we need to check if the router IDs have changed. So the command for doing that is what? Say show. We are at the router configuration mode to start with the word do. Show IP protocols. Show IP protocols. So if you can see that BC3 has 4.4.4, then you know the router ID has actually taken effect. So that is very good. We'll try probably in BC1 and say do show IP protocols. And you can see the router ID is 6.6.6. We didn't need to start the OSPF process. All right. So the next thing is to configure OSPF as so that routing updates are not sent into the networks where they are not required. Very, very important. So we start with the BC2. And if you put your cursor right inside here, which is not the best one, you actually need to click inside the router, and you need to check which interface is currently having this 192.168.4 something. So we'll say do show IP interface brief, IP int dr, IP interface brief, and the interface having going to the LAN of this router BAC2 is actually interface G000. Remember what I said? All interfaces going to the LAN must be configured as passive, and all interfaces going to the internet or ISP or whatever that is must also be put to passive. So I need to say here passive hyphen interface. We do it at the router configuration mode T0/0/0. Okay, and you might want to see my marks changing there. So I press enter and I have 35 now. And I go to BC3, and I'll say do show IP interface brief, and you can clearly see which interface going to the LAN at 5.0. It's interface G00 5.0, and I will say router, sorry, passive hyphen interface. It should be G0/0/0, and that's done. And then we go to BC1. We go to BC1, and we need to look at the interface going to the internet. So we'll say to show IP int brief, and we need to look at the only interface that is not 10.0.1.0. It's not 10.10.0.1 something. It's not 10.0.0, which is the interface going to the point-to-point network, this other side. And it should be the only other interface that's available here is the interface going to the internet, which is having a public IP of 64.0.100.2. That is interface S011. So I'm gonna need to say router OSPF10, and I'm gonna say there passive hyphen interface S0/1/1. Okay, passive hyphen interface S0/1/1. 0/1. And if you want to know that that is actually going to give us some marks there, you press enter, and you can see we have 39. And that's a good one. We need to go this other side, and I need to okay. I need to drag this aside. The only other interface is on P2P2. I need to find these two interfaces and make them passive. So, okay. So the interface going to the LAN on P2P2, I'll need to say do show IP interface brief. And I actually have G001, sorry, G000 and G001. Those interfaces must be put to passive. Say passive hyphen interface G0/0/0. Okay. Then I will say passive hyphen interface G0/0/1. And that's it. And I have now 43. And the only other interface is this one. For P2P3, it also has an interface to a LAN. So I need to say do show IP interface brief. And that interface is actually G00 here. You can see it's going to the work group server down here. So I would say passive hyphen interface G0/0/0. And we are done with that instruction. We are at 45%. So the next thing is we need to, let me just show you that here. We need to configure BC1 with the highest OSPF interface priority so that it will always be the designated router or the multi-access network. Configure BC1 with the highest OSPF interface priority. So we are talking about we need BC1, which is this interface here, to the multi-access network, which means that interface must be the interface connecting to the multi-access network of BC1. And so that interface should be the interface on G01 something, this one, G00. Okay. So we need to set it. So I'm going to exit out of that level and I say interface G0/0/0. I actually need you to be observing my marks here, see them change. So I need to say enter. Then I need to say IP OSPF priority, and it's 255. And it is always going to be the DR here. Press enter, and we are at 49. So if you say do show IP OSPF interface G0/0/0, I should be able to see that this current state of this router is actually here. Let me just enlarge it here. Yeah, here you go. Let me just give my laptop some power here. Okay, just a minute, guys. My laptop might go off soon, so I'm giving it power here. All right, so I think this is done. Okay. So having said that, so you can see here, priority 55, state DR, process ID is 10. The hellos are actually here. The network type is broadcast. Hello is 10. That is 40. We didn't change anything. And the current, there's a designated router which is here, but we don't have no BDR currently here. That's okay. So we have done that as per the instruction. Now, then we are told here, configure BC1 with the highest OSPF interface priority so that it will always be the designated router of the multi-access network. That's done. configure default route to the ISP cloud using the exit interface command. So that is a very important one. Now, they didn't tell us to configure it where, but we need to use our previous knowledge to know that the default route is configured on the router facing the internet, and that should be BC1. On BC1, since we are told to use the exit interface parameter, okay, we need to know which interface is going to the internet from BC1. And so we can actually see that interface here. It is the interface that has the 64, the public IP going to the internet, which is interface serial 0/1/1. So we'll need to say here to configure default route. If you guys can remember, we always say IP route 0.0.0.0 space 0.0.0.0 space. Then you use the exit interface to S0/1/1. Okay. We need to check if our marks are adding up, and we are going to do enter, and we have 55 now. We have 55 marks. And the next instruction was actually saying that we need to distribute, configure, okay, automatically distribute all the default route to all the routers in the network. Okay. Now, since we are going to distribute from the same router we have configured it in, I want us to check if the default route is currently available. So do show IP route. Do show IP route. Yes. Currently, we don't have any default route in this router here. You can see we only have a directly connected here. No static route available. Minimize that. This guy, do show IP route. And we can also see that we currently don't have any static routes here. Okay. The same way, if you went to these other guys on point to point and you say do show IP route, we will not see any static route. We will only see some OSPF routes here. And you can see that the O's are actually OSPF. The C is directly connected. The L is the local route, local interface route. The O are OSPF. No S here. You can see that as well. So since we have confirmed that, let me now get to BC1 and now distribute that route. So we need to say router OSPF 10. Then we say default information, default hyphen information originate, default hyphen information originate. That is a command that you use to distribute the default route. So default hyphen information originate, default hyphen information originate. Now, having done that, I now expect us to see some default routes here. Let me see here. All right, we might not be able to see. I think we'll see it at the end of this activity, but we should see it on this other router on the point-to-point networks here. We should at least see an S. Let me expand it. I know there are a few parameters that we have not finished working on yet, but it will definitely be reflected. So let's finish this lab first, and then we can check that much later. So having distributed that, the next thing we need to do is we need to configure OSPF router so that the gigabit Ethernet interface cost will be 10 and fast Ethernet will be 100. Okay, and we need to do that on unfortunately in all the routers. So we can start with the multi-access. Start here. So the command is, and I want you to see the marks adding up here. So the command is autocost reference hyphen bandwidth, and you put 1000. Do that command. And you go to BC2 and you do the same thing. Okay, you say auto cost reference hyphen bandwidth 1000, and we have 61, and we need to BC3, and we go to auto cost reference hyphen bandwidth 1000, and we are at 63. We go to point-to-point network here. You see auto cost reference hyphen bandwidth 1000. We're at 66. And the only other router is P2P3, which has the gigabit Ethernet interface. We say auto cost reference hyphen bandwidth 1000, and that is actually okay. We're at 66 now. Then the next instruction says configure OSPF cost value for P2P1 interface S011 to 50. Okay. So P2P1 here we need to get to enable conft interface S0/1/1. I think that is the interface. Set the cost to 50. You say IP OSPF cost 50. Okay. IP OSPF cost is 50. Then we are almost getting done, guys. We need to now configure the last of the instructions here. We need to configure hello and dead timer values on the interfaces that connect PC P1 to P1, P2P1 and BC1 twice the default value. So we need to check. I think there are a few things we haven't done yet. We're gonna see that. Okay. Okay. So we need to hello and dead timers on the interface connecting P2P1 and BC1. So we need to know what is the interfaces. So I could go to P2P1. I will say do show IP interface brief. And I know that interface should be 10.0.13. That should be interface S012. Okay. S0/2/0, because the IP is 1.13, must be after 12. S0, we will say interface S0/2/0. We need to set the hello to be twice the default. We say IP OSPF hello hyphen interval, and hello we must put, since the default is 10, put it twice, must be 20. Okay, and the dead, say IP OSPF dead hyphen interval, and if the hello was 20, we multiply 20 by 4, we get 80. That is it. And then we need to go to PC1 server side, and we need to know what interfaces there. So I will say to show IP interface brief, and I will know that is definitely interface S010. So interface S010. So say interface S0/1/0. Say IP OSPF hello hyphen interval should be 20. Then I will say IP OSPF dead hyphen interval should be 8. Okay. Now I'm at 86 now %, and it's time now to do some troubleshooting, because I need 14 more marks to go, something I haven't done before. Before I move on, I could actually start by checking through my instructions. What is it that I didn't do? So did I activate OSPF network statements and ingress masks on routers in the headquarters? Yes. Did I activate OSPF by configuring interfaces on the network device data centers? Okay. Did I do that? I don't know. I don't know whether I did that. I needed to go to the interfaces here. I need to get here, and yeah, I think probably this is where I might have made some mistakes. So to show IP interface brief, and I know that I have two interfaces and three interfaces on this guy. So I need to say I need to say, all right, I get it, I get it, I get it. Headquarters network, this was a point to point. So I need to say, right, this is one, 10.00.12, which is interface S010. So I needed to say, okay, I think I did it. I needed to say interface S0/1/1, and I'll say IP OSPF 10.0. And the next interface is interface G000. So interface G0/0/0, IP OSPF 10.0. Then interface S010. Interface S010. And you say IP OSPF 10.0. So I did that on BC1. I need to do that on BC2 as well. If I say do show IP interface brief, so that I know which are the two interfaces. So then I say interface G0/0/0. I need to activate interfaces for OSPF. Say IP OSPF 10.0. I think I didn't do that here. And probably this is a good time also to see if my marks are adding up. And I'm at 91. So I didn't activate OSPF on these interfaces. And that is what I'm doing right now. So I do now G001. So let's say interface G001. I say IP OSPF 10.0. Good, I'm at 93. And I need to do the same thing on BC3. And BC3, I need to say do show IP interface brief. And I know that I have two interfaces on BC3, G000, G0. You can see they are currently active with IP addresses. So I need to now get into those interfaces, G0/0/0. I say IP OSPF 10.0. The step I skipped. And then the last one is G001. I will say IP OSPF 10.0. And I have two more marks remaining, which means there's something definitely that I haven't done. And ladies and gentlemen, this is the right time to use check your results because I'm at 98. I need to know two more marks on something that I haven't actually done. So I'll go to, the assessment items there and look at where there's an X. I definitely have to find it. Oh, okay. So I need to do P2P1, the auto cost reference bundle. Okay. P2P1, here, I needed to configure the auto cost reference bundle. I get it now. So I needed to say exit here, and I say router OSPF 10, and I needed to say autocost reference hyphen bandwidth 1000. I don't know whether that is gonna make my work to be easy here. And there is it. There we have it, guys. We have just hit the 100% mark, and we need to do the last thing of verifying this network. So the first thing I need to do is I need to check in this router if I say show IP route. Do I have some routes here? Yes, I should. You can see there are a lot of OSPF routes here. And I'm waiting to see at the very bottom here. This is the route, the default route that has been distributed inside OSPF. And you can see O, which means it's an OSPF route. The asterisk means it's actually a default static route imported. It's an external route type 2 imported into OSPF. And the AD is 110 here. And if you look at it in BC1, we are actually going to see it's with an asterisk S. So I do Control Z and I say show IP route. And you can actually see that at the very bottom here, we'll see the default static route here. So where we configured it is actually a static route facing the internet through the exit interface S011. And if you go to any of these routers, I think you should be able to see it here as well. And I say show IP route. And I actually expect you can see it here. Even the point-to-point networks, they have learned some OSPF networks here. Several of them learned using OSPF, but the default route has also been the type 2 external route has been imported into OSPF, which is a default static, and you can see it right here, so on and so forth. And you will see that in every router here, show IP route. And I expect to see it in all these routers over here. You can see at the bottom here with the external type 2 route, default imported into OSPF. And of course, the other OSPF routes here. Of course, we could still say show IP route OSPF and to view only the OSPF routes here, and you're gonna see them only the OSPF routes being seen right here. OSPF is a dynamic routing protocols used within ISPs, and this is one of the most common dynamic routing protocol. You find it in every organization, Safaricom, name it, they use OSPF, Someone has a question?
Can you show us the protocol that we can see the DR, the BDR?
Okay. So that's a very good question. So the BDR and the DR are elected among the BC1, BC2, and BC3. So let's go to BC1 and let's see who is the BDR and who is the BDR. So I'll just say show IP OSPF interface G0/0/0, the interface participating into SPF. And if I get to do that, we should definitely see here that currently the DR is BC1 and the priority is 255. The DR, which is the local router we are in right now, has a router ID of 6.6.6. The hello is here 10, there is 40, so on and so forth. So, and of course, the network type here is broadcast. We do BC2, and let's see what is the status here. So, show IP OSPF interface G0/0/, I think 0. And clearly you can see the current state here is the current. Let me see. Seeing something very abnormal here. Let me see which interface is currently participating here. Show IP. Show IP IP interface brief. The interfaces participating up there should be not 10 for G001. Yeah. So let me see for G001. Yeah, so I expected G001 to be the BDR. Okay, even though it has a priority of 1, it will be using the, I think, the router IDs to be basically to do that. So the state is BDR, but the designated router has 6.6.6, which is actually R1. For this other router BC3, let me see the interface participating. If you say do show IP interface brief, the interface participating there, it must not be 5 or something, must be interface G01. G01. So let me say do show, right? So show IP OSPF interface G0/0/1. So I expect this router to have a set of DR other, since BC1 is the DR, BC2 is the BDR on the interface, and then BC3 is the DROTA, all right? And tell us who is the DR here, 6.6, who is the BDR, because it's 5.5. Okay, the hello and the dead are obviously right here. Okay, I could even go ahead. Of course, I hope you saw that, you know, the network type currently is broadcast. It's a multi-access broadcast network. For the P2P network, let's be able to see all those as well. So show IP interface brief. And let me see interface 10.0.0.1 or 10.0.0, 10.0, serial 0.1.1. So we'll say show IP OSPF interface S0/1/1. And I expect to see the state of the network here. The network type should be point to point. And of course, the process ID is 10, router IDs are found here, and 10 and 40, the hellos here. And yeah, and if I check on maybe interface S010, I should see something a little bit different here. Still point to point, but the cost is a little bit higher. And of course, 10 to 40 is the hello there. And that's it. I could do probably here. Let me get here and just say show IP OSPF interface. Maybe S0/0/1. No, there's no such interface. S0/1/0. Invalid interface number. This is P2P3. P2P3, I think, was having show IP interface brief. It only had S0/ no, it only had S0/10 and 11. Show IP OSPF interface S0/1/0. The type is point to point here. You know, intervals 40, 10 to 40, and so forth. Yeah. Yeah, I think that is actually, you know, trying to, of course, we can check some neighboring here. Show IP OSPF neighbor. And you can see this guy has a couple of neighbors here. And the neighbors are actually having, let me find it. Yeah. So the neighbor is 666 and 444 is there, and it's full and DR, full and DROTA here. And the timings are here. The interfaces are there as well. So you can view neighbors, you can view so many settings. Yeah. Any other questions, guys, before we get done? It's already at the top of the hour. It's exactly 7:30. Any other question, clarification? Someone might make.
From any of the needs to the internet.
Just say that again.
Can you ping whether it will be successful from maybe?
Oh, okay. Let me do that. That's a very good one. Yeah, that's a very good reminder. So what I'm gonna do, we were told that all the routers were supposed to ping all the way to the internal server. Let me start from PC1 here and see if they are actually going to ping. All right. So let me ping. It's the IP of the internet server somewhere in the internet is 203.113.100. And let's see if the results are going to be coming back here. Let's see if we get some replies here. Obviously, you can see we missed one. There's a request timeout, but the rest were actually this. And if we repeat that, we'll actually get to see they were able to ping a remote server. If we do that from the laptop here, go to the desktop and do some pings here. So ping 203.0.113.100, and you can see we're getting feedback here. Perfect feedback. We could ping probably, let's ping in another network now. And say ping 203.0.113.100, and clearly we are getting replies here. We can actually try and ping PC3 probably from PC1, and we could check the IP address of PC3 by going to its IP, or just saying here IP config space R, and we see that the IPv4 addresses are here. For PC3, this is the IP address 192.168.5.50. So I'm gonna ping PC3 from PC1 right here, and I'll just need to do a ping and put the IP there, and clearly you can see that there's communication throughout my network. My network is completely reachable from any part. They can ping the internet, and they can even ping from another headquarters, from the data services to the headquarters, back and forth. Yeah. So yes, it is able to ping, and traffic was actually moving there. And we could even do, a simulation ping, and I could just edit my filters here, and I'll actually leave HSRP out and RIP out, and remove BGP, and remove EIGRP, remove DNS, and probably just remove DHCP as well. And I'm gonna leave, of course, OSPF packets, or I could even remove the OSPF packets, but let me leave that for now. And what I'm gonna do is that I am going to pick simple packets here. All right, I'm going to pick my simple PDU packet, and I'll put it on the laptop, for example, and I put it on the internet server, and I'm going to, let me edit the filters a bit so that it takes a little bit of time here. I'm gonna leave this, probably remove OSPF as well, because I'm not testing OSPF. I'm testing if ping messages can actually go through. So I'm gonna click start here, and you can actually see traffic is moving from the laptop to the switch to P2P2, And P2P2 sends it to P2P1, and P2P1 is actually, sending it all the way to the router BC1, and BC1 takes it to the ISP cloud, and ISP cloud sends it to the internet server there. And let's see if the internet server is going to give us a feedback. And you can see the feedback coming to the ISP cloud, guys. And the ISP cloud is just a couple of routers there, sending it to BC1. And BC1 is actually going to send it all the way to P2P1 router. And P2P router needs to send it to P2P2. And P2P2 obviously sends it to the switch. And the switch takes it back to the laptop. Okay, so that was a very successful activity we did here. Now, so the thing is, this thing is it's only let's move it, take it back to real time. It's very easy when I do it, but I think it will only work better if you do it. So I want you to add, please, the class representatives on the list of the assignments. Add 271. 271 should be added there as an assignment. Now, before we get closing, since this was very successful, I want to draw your attention to 2 more activities. And one of them is actually an activity on, these ones are simulation labs, very, very important. And Cisco takes a lot of activity to design some of these labs. Remember, our learning has been on single area network, single area OSPF, okay? So Cisco have designed some labs here on multi-area network. And so we do have 273. There's this another, yeah, all of them are actually 273, but they're exploring different things, okay? So we have, this is the part 1, and if you click, all these are in your activity 273, part 1, part 2, and part 3. If I click there, I can actually open the corporate headquarters, and there's a wiring closet here. I'm gonna click on it, and there's a lot of things to be learned from here. And you can actually see that there are some routers and switches here, and there's a major router that is actually here, and you can actually explore inside, and you can view the routing table, show IP route. And inside this router, you actually get to see, a lot of OSPF protocol. This is within a data center. You expect to see so many routes over here, okay? And this is part 1 of it. Let me check part 2 of it. And part 2 is actually here. I will also click on that, and the Sao Paulo is here, and click on the headquarter network, and click on the wiring closet, and can actually just click on this router here to open it and enable and say show IP route, okay? And there exists some routes over here. This is an area border router, and this second one, of course, there are instructions here that are going to be guiding you as you explore. These are exploratory packet traces to just give you a rough idea of, and I think you will even put your hands in terms of configuring these area border routers. And if you want to see more, follow up. And when you get to part 3 of it, this is where now the multi-area is actually operational. And if I click the Sao Paulo now, and I go to the headquarters, and we need to see some area border routers. And if I do this, and I say show IP route, you'll be able to see, let me just find this. You'll be able to see something like this. And to tell you more about it, that is actually an inter-area. That's an OSPF route, which has been learned from another area. So we do have this topology here. We have the branch offices here, the corporate headquarters is actually here. And then now we have these two routers that are between two areas. So this is actually area 0. This is area 1. And this is area what? Area 51. So the routers that are found in the middle here, they are called area border routers. And so they will actually be carrying traffic from one area into another area. And it is in them that you'll find things like the inter-area. A route learned using OSPF, but that route has been learned from another area into, for example, the area 0. Okay. And if we went to, for example, and you say show run, you will actually see things like, let me just see that. You will see OSPF configured, and you will see network, put the wildcard mask, when you put another area now. Look at the interface where that router is. I mean, the area where it is, and some will be on area 1, some will be, of course, on area 0. If I can check on, for example, ABR, something on area 51, ABR1. Let me open this router. Yeah. So go there and just say show run. I'm just giving a test, and these are things you'll find in CCNP. And we teach CCNP at Kenyatta University here as well. So if you let's look at how this one was actually configured. I think you are going to do some implementation here. You can see this is only having area 1. I want you to see something on area 51. And if I check on this is AS on the branch. So let me go back on the branch network. Okay, let me open branch here and branch closet and open any of these routers here and check on that. Check on this. So I do EN and I say show IP to no, show run. So let's be assured this is the last one I'm doing so that we can get going. Look at all this one should actually be area 51. Okay. So you configure the networks, the directly connected networks, depending on which area they are. If these ones are all area 0, give them area 0. If this is area 1, all the routers here will be area 1. These ones are all area 51, all routers here will be area 51. A router like this one interface is in area 0 and one interface is in area 51. That's how you label the areas like that, so on and so forth. And this is so, of course, area 0 here, something like this. So explore 273, part 1, part 2, and part 3. Guys, we're late. We need to go now. And I want to stop there unless there's a question. Anyone with a question before I end this activity? Anyone with any question?